Hi, I'm Matthew, and in this video I want to talk to you about how I ranked first at university in mechanical engineering. So I went to the University of Portsmouth and graduated with a master's distinction, and I was awarded the Frederick Barnes Waldron Award from the Institution of Mechanical Engineers, so IMechE. This award is reasonably exclusive in that only one is awarded per university, and it is awarded to the student which the university considers the best student. And that basically boils down to be consistently scoring higher than your colleagues. Usually that will be through getting really high exam results and coursework. So some of these points are really targeting doing well on your exams and on your coursework. One of the key frameworks that I work with in engineering is a model where you pay attention to the theory, then you practice questions using that theory, and then you try it yourself. And that's something which I used all the way throughout university, and I found was really powerful to be able to do consistently high results. And you may have heard of this model from other people and other YouTubers and other sources, which is a model which is based on read, recite and review. And it's just a really powerful active recall technique to learning. So I've got 9 tips, in my opinion, on what led to my success in ranking first at university for mechanical engineering. And the first one is based on creating a formula sheet. You might have some closed book exams or open book exams, but it doesn't really matter. I found this technique to be useful no matter which of those it was. And then if it's a closed book exam, you can just take away the sheet and then you can focus on being able to memorize those equations. So you can start off with just learning how to answer the questions. And once you're good at that, then you can take away the formula sheet. And then you've just got to remember what these equations are as well. I find that creating a formula sheet is good for just getting you introduced into your revision time. So it's usually the first thing I do during revision is just put all my knowledge onto one A4 piece of paper, or 2 sides perhaps maximum, that's it. And just have it all in one place, and I can use it as a guide when I'm going through my questions as well. That would lead on to the second thing, which is practice exam questions. And this is the most powerful thing that I did. It's the reason why I did well, is that you just practice questions over and over and over again. And you might say that you don't have many practice exam questions to actually go through, but I'd probably say that's not strictly true. You can probably find ways of getting questions. They might not be exact, they might not be exactly the same style or the same format that you might get in your actual exam, but it should be close enough. Your lecturer will have given you a bunch of exam practice questions that you can go through. And maybe there aren't very many, but what you can do is you can recycle them through your revision period. So you could start off with those questions. You can do questions from other exams or other topics or from other sources, and then you can go back over them again because you probably won't remember them. The next thing that I did when I ran out of lecture questions is I actually just went through some of the textbooks. So I've got a lot of good textbooks on most of the course subjects to actually help me give me more questions, and a lot of these textbooks actually had answers too. So just a few of them. We've got Solid Mechanics here, which is done by Professor Carl Ross. Really brilliant book. He was actually one of my lecturers. There's a lot of good questions in there with answers as well. For Dynamics, I had this Engineering Mechanics Dynamics book, which is by Meriam and Craig, really good. Then I've got Mechanical Engineering Principles by John Bird and Carl Ross again, which is probably a little bit more high level. It's probably more aimed at first year, but also found it's quite a good reference for a lot of the courseworks that I would write. And then I've got Thermodynamics and Engineering Approach by Sengel and Bulls, one of the ones that I probably use the most. And then also, because this previous book didn't have everything that I needed for my thermodynamics topics, I also had Fundamentals of Aerodynamics by John Anderson, which helped with some of the fluid flow questions as well. So all of those combined were pretty good, and they captured most of the core subjects that I needed. I highly recommend these books, and these ones are probably the new editions compared to the ones that I used, but I'm sure they're just as good as the editions that I used. So there are some links in the description to these books should you wish. I'd also say that there's a third way in which you can get questions, and that will be to create your own questions. So if you look online, you will find plenty of online calculators for these sort of engineering questions. So I found one on beam bending theory, so I could create my own problems, and then I just had to work out my own, what am I looking for, and I'll just write a question of me finding the deflection of this beam, for example. The online calculator would give me evidence that actually I'd gotten the right answer. And if you're concerned about whether the actual tool works, then you could try the tool out on the web, compared to some of the questions which you have known examples for, so some of the ones your lecturer has given you or some of the textbook. So you can try and vet whether the tool works properly. Moving on to coursework, I'd say that going above and beyond in coursework is really what's going to make you stand out and get good scores for your coursework. So I remember one of my courseworks was based on a lab that we did when we had to, it was based on the combustion of methane. We burnt methane in a controlled environment, obviously. So we measured all the exhaust gases, or most of them anyway. And then we had to write up a report on basically what we did. And there was the exhaust gases for stoichiometric combustion didn't really reflect what we saw in the results. So I proposed why that might be the case. So I had a look at the combustion calculations for both lean and rich examples of the lab that we did, and found that actually the results of the lab actually aligned really well to my proposal if there was, say, 5% less or more air than what we used for the burning of however much methane we were burning. So it was going above and beyond what probably other students had done, and therefore I got like 90% on that lab report, where typically we'd only get about 80% for most of the labs or courseworks. So it was really one which I scored highly on, and it's probably because you go a little bit further than what the lab wants you to do. You've got to remember that these lecturers are probably looking over the same coursework and it all probably looks exactly the same, probably a bit boring. So maybe there's an element of they've done something interesting and I'm going to score this well. So these next 2 points are really based on something which I think is kind of like a kinesthetic learning thing, if you like, and will really help basically all areas of your engineering, as well as through to university as well. So the 4th point is placement years. So I noticed a step change in my performance after I did a placement year, and that's because you're in a professional setting and you're actually applying what you've learned to work, and you're getting an understanding of what work will look like. And I think you really then go, that's where that equation fits in, and that makes so much more sense now. I can see the bigger picture. It's not just theory and text on, it's actually products maybe you can hold in your hand, see on CAD or that sort of thing, and it really becomes more real. And therefore I think because you have more experience of it, you can see the experience, you can recall the experience, some of that learning actually becomes more interesting, and so you can probably recall it, remember it better, and apply it to your future years in academia. And so I'd really recommend a placement year if it's something you're considering, and I think it'll be a really powerful thing for you to do. Following on from that trend, the 5th point I have is formless student. Is formless student something that you can do at your university? If you can, do it. It's amazing. You can learn so much from it. You might not have the best team, you might not have any team, but if you can start a team and get it involved, you'll learn so much, and it's just incredible how much you'll learn. And things like manufacturing, materials and manufacturing, if you have topics these at university and you're going to have exams on them, you will be able to do so amazing at those topics, because you have to work with those in formless student anyway. If you don't, your car's going to break and you won't go anywhere, or it just won't fit together. So you have to know about materials and manufacturing to do formless student. As you go up in experience, you're going to need to know all the formulas for mechanics and statics as well. You're going to be applying those directly to something you find interesting, hopefully, and so you'll be able to recall them really easily. So my next point is listening in lectures. Is note-taking really something that's going to help you? Is it just for the sake of it? Are you really getting anything out of just taking notes? I find that some of the lecture notes are really good. Certainly in some of the lectures that I went to towards the end of university, they just give you a whole pack of notes. And yes, I could highlight things and everything. But what I found actually was just to listen to the lecturer. So I can't get that information from the lecturer back again. They're saying a lot of useful things there and then. I can always look at the notes later on and I can remember, oh yes, I remember him saying that. I can go through and highlight as I want. So you could go through your notes after the lecture. This might not be what you want to do, but should you wish to rank highly, then it might be something you want to consider. I realised quite early on that actually taking notes didn't help me. So I listened to what the lecturer was saying rather than take notes. My 7th point is to pay attention to the question. The question holds, in your exam, holds all the information you need pretty much to be able to answer it. And what I used to do is I used to go through the question, and as soon as I hit like a parameter for an equation, I'd then write the symbol for the equation equals to whatever number that I have. And if I don't have the numbers to a various parameter, I'd put a question mark. So if I had a beam bending question, you might say that the length of the beam is 2 meters long, so I'd go, okay, L equals 2. And then you might say, so the depth of the beam is 10 centimeters. So I go, okay, that's 10 centimeters. So D equals 10. So I'd go through the question, recording all the numbers versus the parameter, but also pay attention for things like special words like isobaric, homogeneous, isothermal. Those are all really big clues for, say, a lot of the thermodynamics questions I found. The 8th point that I have is have an idea of what the answer should be before you finish the question or before you move on. So going back to the beam bending example, if I have a beam of 2 meters long, and you've got a steel girder, which is like 10 centimeters thick and 10 centimeters wide, and it's an I-beam, if you like. If I put 1 kilogram of sugar in the middle and have supports at either end, the beam isn't going to bend by half a meter. So if you get an answer of half a meter, you know it's wrong. So have a good idea of it and really, say to yourself, this is my answer. Does that seem right for the thing that I've got? If I've got an engine, it's not going to have a 90% efficiency. It's going to be more like 30, 35%. So have a good idea of what answer you expect before you move on, or at least at the end of the exam. Don't just leave because you can leave half an hour before the end or of the exam or something. My last point, my 9th point, would be something which probably everyone gets wrong at least once, is pay attention to your SI units. And it's so simple, but it catches everyone out, and it might only be worth a few marks for the end mark, and you may have gotten all your other marks for your method and whatnot, but you want to rank high. So just fix this simple mistake and make sure you're using SI units or convert to the right units. There may be 1 or 2 cases where you're not specifically using SI units, but if you convert to SI units, you shouldn't really be going wrong. Things like millimeters are probably a big one which catches people out. It needs to be meters, kilograms, Kelvin, so temperature is probably one of the big culprits as well, not Celsius, Kelvin. Just bear all of those things in mind, perhaps go back through those points. I found they work for me. They might not work for you, but perhaps just experiment as well, see what works, and I hope that's helped. Thank you, and I'll see you in the next video.